Hello and welcome to the Unit 3 Section 1 video on graphing relationships. So when we're graphing relationships, we're basically taking two different things and we're comparing them. And what we're doing is normally comparing something in terms of time. That's something that you're going to see most often here, but it can be really any two things. But here we're talking about time. So we're going to just do a few examples of graphs rising, falling, or staying the same. So here we have a graph. If you read it from left to right, it's going down. So therefore, we say that this graph is falling. For the second graph, since it has one straight line going across, we say this one is staying the same. And then for the third graph, we have the graph rising, because as we go from left to right, it's going up. So this graph is rising. Okay, so that's three different types of graphs and the way that they can behave as we go from left to right. So now that we've kind of stated the obvious here, let's just talk about what this means. Okay, so if we are increasing, then we know that the graph is going up from left to right. And an example of that would be very much like what we saw on the top right. You have some graph with some axes, x and y, and the graph is going up. A graph that is decreasing is going down from left to right. So again, if we have some graph, we can say that it's going down from left to right, kind of like that. And then a constant graph is the graph that stays the same from left to right. And we saw that in the middle example at the top, and so we'll draw another one. Here's another example of that. Okay? So let's do some graph identification here. We are going to choose the graph that best represents each situation. So the temperature of the water in a glass remained constant. If the temperature remained the same all the way through time, then we're talking about graph B here. If the temperature of the water in a glass rose steadily for several hours until it reached room temperature, then remain constant. So the temperature of the water rose steadily, kind of like here in graph C, and then it stayed at room temperature. So that would be graph C. And then if the temperature of the water in a glass cooled down steadily with the addition of ice, then remained constant once the ice had melted, that would be graph A. All right, let's look at another example. So for number 7, a tomato plant grows taller at a steady pace. So if the tomato plant grows taller and it's doing it at the same pace all the way through, that would be graph C here. If a tomato plant grows quickly at first, then remains constant height during a dry spell, then grows at a steady pace, well here in graph B, it's growing constant at a fast pace, but then remains constant during the dry spell, so it doesn't grow at all, and then starts to slowly grow again. So that would be graph B. Then if a tomato plant grows at a slow pace, that's graph A here, at a slow pace, and then it grows rapidly with more sun and water, so it goes faster at the end. So that would be graph A. Let's check out this trio of graphs. So a person leaves home, drives through town, then on a highway, and finally stops at a rest area. So if they leave home and they're driving through town, they're going fairly slow. Then they drive through on the highway, so they're driving faster, which is here on graph A, and then finally stops at a rest area, so we're not moving at all here at the end. So this one would be graph A. All right, a person leaves home, drives to the other end of town, buys groceries, and then returns home. Well, that's like graph C, because if they drive to the grocery store, then they stop at the grocery store for a while they're buying groceries, and then they drive home, returning to where they started. So that would be graph C here. And then finally, a person walks to a friend's house where she stays overnight. So she walks to her friend's house going pretty slowly, moving away from home, and then stays away from home the rest of the night. So that would be graph B. Okay, let's talk about writing descriptions of graphs. So we want to be sure to include a description of the x-axis and a description of the y-axis. Whether the function is increasing, okay, so we're going to state whether a function is increasing, let's say staying the same, or decreasing. And then we also want to notate any change in the graph. So for these two examples, we're going to write a possible situation for the graph. So here we have the number of passengers versus the number of subway cars. So with each subway car, we're able to add another 40 passengers each time. So as the number of subway cars increases, more passengers can ride. For example 14 here, the weight of a person typically increases rapidly as they grow up, as they go through childhood and adolescence. Once they become an adult, their weight gain, or at least a teenager, they may start to gain weight a little bit slower until they eventually reach the weight that they're going to be, ideally, for the rest of their lives. Of course, we know that's not necessarily true. People do tend to gain weight as they get older, even as adults, at a slow rate, but here we can say the weight of a person increases as they get older, then increases more slowly once they are an adult. All right, let's take a look at these two situations. Well, here we have the weight increasing by 10 pounds versus the number of packages we have. So here we can say the weight of a shipment increases as the number of packages increases. And then for 16, we have the speed going constant at 25 miles per hour for 5 hours, or I should say 5 seconds. And then it speeds up and eventually starts to move faster here from 9 or 10 seconds on. So if the speed is slow at first and then picks up, we can say a car leaves town, then accelerates as it merges onto a highway. So you notice we don't have to be too incredibly specific, just good enough to give a description of what's happening here. All right, let's take a look at sketching graphs. So we're going to go the other way around. So Erica walked from her house to a friend's house, watched TV, and then walked home. So here's the distance from Erica's home, Erica's distance from home, and over time. Well, she walks to her friend's house, so she moves away from her home. She stays for a while and watches TV, so she's not moving at all, and then walks home. And so our graph is going to end up looking like this. A subway train leaves the station and accelerates at top speed, or to top speed. Okay, so here we are from distance from station A. It leaves the station and then starts to accelerate to top speed. Then it maintains a speed before it stops at the next station, and once it stopped at the next station, it doesn't move at all. So let's try this again. So we're moving away, and then it's going at top speed, and then it stops at a station. And this part of the line should be horizontal. Let me try to make that look a little bit more horizontal. That's good enough. And then finally, we have a hiker hiking toward his campsite at a steady pace until he rests for water and a snack. So he's going away from his campsite at a steady pace, stops for water and a snack, and then he continues at the same pace until he reaches the campsite. In fact, I drew this backwards because if you notice, this is the distance from the campsite. So eventually he's going to reach the campsite. So he's walking toward the campsite, stops for a snack, and then continues walking toward the campsite until he gets there. So the graph should look more like that. All right, that does it for section 1. That's kind of a brief introduction to graphing relationships and being able to describe what a graph is doing. In fact, we need to add one more section to this before we completely wrap things up. Let's talk about independent and dependent variables, just kind of as a postscript to this section. So an independent variable represents the x-axis. So here you're going to think about the input, okay? And then the dependent variable represents the y-axis. And here you're thinking about the output. This is what the result is. Okay? So let's do some examples of this. Mr. Smith wanted to see if the color of light shined on a plant had an effect on the number of leaves it had. He gathered 2 groups of the same species of plants, gave them the same amount of water, and did the test for the same amount of time. On one group of plants, he used white light, and on the second group, he used red light. So, what is our dependent and independent variables? Well, the independent variable is the one that we can't really control. And the dependent variable is the one that's response. So think about independent as your cause and dependent as your effect. Okay? So what is our input here? Well, our input is the color of light. And our dependent variable, or our output, our result, is the number of leaves. And that's all there is to it, to identifying these. So let's take a look at the next one. You're managing a large feed of cattle. A pharmaceutical company wants you to try a new antibiotic to treat shipping fever. You are currently not using an antibiotic. The company claims that it is more effective and will save you money. You will use the same feed, water, and conditions of the cattle. You measure the temperature of the cattle's fever. So here, what we are changing up is the use of antibiotics. And what we're looking to see the response of is the temperature of the cattle's fever. And then finally, for this last one, a shopping mall wanted to determine whether the Tough Stuff floor wax was better than the cheaper Steel Still at protecting floor tiles against scratches. 1 liter of each brand was applied to test sections of the main hall of the mall. The test sections were the same size and covered with the same types of tiles. After 3 weeks, the number of scratches in each test was counted. So here, what we're changing up is the type of floor wax, so the brand of floor wax. And what we're looking to see in response is the number of scratches. And so this is the type of information that we're putting on our X and our Y axes. Okay? All right, so now that wraps up what we want to talk about in this section as far as how we can interpret relationships on graphs. So coming up in the next section, we're going to talk about functions, relations, and data sets, and we're actually going to start talking about putting things on graphs and how x values and y values are related to one another.